Hey, welcome. In the next 10 to 15 minutes, I want to talk about the lessons we learned while developing for the HoloLens since 2015. And I want to share some of the best practices and my recommendations for HoloLens development. Actually, I want to share my top 10 HoloLens development recommendations in this talk. And as you can see, this is part two about my developer lessons learned. And part one was presented earlier today and will also be presented throughout the next couple of days here at Build. So make sure to stop by later. And I will also have the times on my last slide when you can see the other sessions we're presenting here. So in this session, like I said, I want to show you some of the learnings we got since developing for the HoloLens since 2015, since we were part of the first wave of the HoloLens Agency Readiness Program, and we developed like maybe 2 or 3 dozen HoloLens applications since then for different clients and various verticals and scenarios. So that was a great so far, and yeah, and when I talk about the HoloLens, I'm not just talking about the HoloLens device itself, I'm talking about mixed reality. And mixed reality also means the new headsets Microsoft is releasing together with the partners, OEM partners like Dell, Lenovo, HP, Asus, Acer, and so on, right? So we're talking about the occluded mixed reality devices here as well when I talk about HoloLens. A lot of those things apply to the same. And because with the mixed reality Windows platform, we basically have the same API set for the HoloLens device, also for the occluded mixed reality devices. So a lot of those things apply. Of course, there are some design changes and design considerations that are different, but really most of the things here apply as well. A couple of words about myself. My name is Renny Schulte. I'm Director of Global Innovation, and I also run the Immersive Experiences team at Valorum, and I'm a Windows development MVP as well. I have a background in computer graphics development, VR and AR, and one open source project I was doing is called SLAW Toolkit, which was the Silverlight augmented reality toolkit, a port of the AR toolkit for Silverlight. Yes, Silverlight, that was very old, as you can imagine. Who actually remembers Silverlight here in the audience? Ha, awesome, right? So that was a good time and good learnings, definitely. And those a lot of those things still apply these days, especially when we're talking about immersive technology and mixed reality. All right. So in the next slide, I want to show you a video about the company. It's not very long, Valorum, and this video will show you some of the HoloLens work we did and but Valorum is much more than that. So we also do Azure development, Office 365, Microsoft Teams, and whatnot. So we do a lot of things, mostly with the Windows stack. But the UX team at Valorum also does Connect apps and Xbox apps and iOS and Xamarin and whatnot. But really, my focus here is, of course, the Immersive Experiences team. And this video will tell you a few things about the development we did for the HoloLens. All right. So let's talk about the top 10 HoloLens developer recommendations I have here for you. So first of all, the HoloLens is a very unique device, as you know. It has those mixed reality, uh, also those special lenses, right, that can blend virtual objects into the real world. And it also has this spatial mapping capability. So it can map the room. It has this inside-out tracking technology. It knows where it is in the room. It can also map out the room, which means you can actually anchor and place holograms at the real object. So instead of having a hologram floating in air, it's better to have it like placed on a table, to have it anchored there, to have it stable at the position. Another very unique feature is actually a multi-lens solution. So you could connect multiple HoloLenses together and they can interact with each other, and also the viewers can see the same holograms together, which is an amazing piece and gives a lot of use cases for collaboration in professional field and so on. So this is a very good and unique feature. This doesn't work with occluded devices, of course, right? But with the HoloLens device itself, the multi-lens feature is very awesome. I mean, then again, if you want to do it with occluded, you can still find a way. You would have to show a virtual avatar or something for the other person. So there are definitely ways to solve that. But it's the HoloLens. The great thing is really the see-through lenses, and that you can walk around, work with that. So leverage its uniqueness. That's the case, and I have not seen any device that comes close to what the HoloLens can do on the market. So I tried out a bunch of competitors which are available, but none of them comes even close. Treat the HoloLens as a mobile device. As you know, it's actually the HoloLens is a mobile computing unit. You have a computer on your head. So all the computing is done on the device. There's no cable needed, nothing. But this also means you have, of course, constrained hardware because you cannot put in like a full-blown NVIDIA 1080 graphics card into this thing because it would probably melt your brain, right? So of course we have limited hardware on it, but it's still pretty impressive. Don't get me wrong. It's pretty impressive what the device has built in. I'm still blown away every day. But we need to keep in mind, especially when we're rendering something. So for both eyes, we have those special lenses, and each of those has 1 million pixels resolution. And what we notice is that the HoloLens device is mostly fill rate bound. So you can easily render a polygonal model with 100,000 polygons. That's possible. No big deal. But if you render it very close to the user, it will occlude a lot of the holographic frame, which means a lot of pixels need to be filled. And if you have a heavy pixel shader and a heavy computing for each pixel, then the frame rate will drop quickly. So you cannot use the Unity standard shader, for example. It's just too complex. So you want to have a specialized shader. And for example, here for the Tire Explorer demo we're showing, we wrote all custom shaders for the tire pieces to still have them looking very nice, but on the other hand also have a good frame rate because we want to keep up with a real-time frame rate to make sure that the holograms all stay stable. So keep that in mind. You need to optimize your experience quite a bit if you want to have a high fidelity rendering, but still real-time frame rate. Another important piece is the HoloLens actually has a small CPU. It has an Atom CPU, but it's still multi-core, so you can do some multi-threaded computing. Of course, you should not overdo it, but for example, if you have some background data you want to fetch in a background thread, then you can do this in an extra thread, so you can keep the UI thread not too busy, and the UI thread can keep up with the rendering loop to make sure you're staying in the real-time frame rate range. Design for the holographic frame. So here's an important piece. So the holographic frame, or field of view, as some of them call it, we hear it often, and you probably notice that as well on blogs and so on. It's often the main criticism point of the HoloLens device. Although, if you use the device for a bit longer, you don't notice it anymore. It's gone pretty much. You don't realize it because first of all your brain adapts, but second of it, you also need to design properly for the holographic frame. So let me give you an example. If you want to render the tire, for example, right? So you take the tire and you could place it very close to the user so that it's actually not fully visible in the holographic frame. So then it's basically cutting off the top and the bottom. Or think about like an Earth globe you want to render. If you put it very close to the user, the hologram, then it's cut off, right? You only see a middle part of it. The top and the bottom is cut off, and so basically you're showing to the user, okay, you're not seeing everything all the time. One thing to solve it is you put it a bit further away. So if you put it like 2 or 3 meters away, reduce the scale a bit, at least for the initial experience when the user puts on the lens and launches the app, then the user can see the full thing and it doesn't actually notice there's a holographic frame that is, not including the full vision. And so that is an important piece to keep in mind. For example, we also have another app called HoloTire, not to be mistaken with Tire Explorer, but for HoloTire we allow a placement of a virtual podium in the room, and we only allow the user to place it at a certain distance. So if the user wants to place it too close, we actually show a red indication and give the user a sound if they want to place it. So we only allow a placement at a certain distance to make sure for the initial launch it's fully in the field of view. Yes, think outside of the box. So there's this Holobeam application we're developing where we're using a 3D camera and we're taking a 3D camera data, and you see that basically here on the the backdrop of the slide. So this is what we render in the HoloLens with the 3D camera data. So we take that 3D camera and stream that via the networking connection into the lens in real time. And it's not just 3D cameras. If we think about IoT these days, we have sensors everywhere, right? Light bulbs and whatnot, it's all over the place. And HoloLens has a very solid networking stack. It has the Windows, universal Windows platform networking APIs built in, so you can use streaming sockets and whatnot. Also, the HoloLens supports Wi-Fi standard AC, so very high bandwidth actually, and you can do a lot of things with it. So think outside of the box, use some of that, and this is where you can, extend even the awesome sensors the HoloLens has. You can extend them with much more that is outside of the HoloLens. Yeah, let it focus on the important things means the HoloLens has an API called Stabilization Plane, and you want to use that. So the stabilization plane is basically a 3D plane. So a 3D plane, if you don't know, is pretty much, you can define it different ways, but one of the easiest ways, you take a point in 3D space and then a normal that is defining where the plane is pointing in which direction. So you take that 3D point and a normal. And by default, the stabilization plane of the HoloLens is 2 meters away and always facing the user. And what the stabilization plane does, it makes sure that in this plane, all the rendering and the holograms are the most stable. So you want to leverage that and actually tell the HoloLens where you want it to be most stable. And you could do this, for example, you could define, okay, this certain hologram at the certain point should be stable. So you can set the stabilization plane to be at the point of it to be at that position. And then you could also set the normal to be facing the user. And you can also dynamically adjust that. So that's a very important piece to keep the hologram stable and not jitter when you move. So that's very important. So take a look at the holographic settings, set stabilization plane. Very important API. Then get your holograms anchored. So the HoloLens supports the concept of so-called world anchors. And what you can do there, you can apply a world anchor to your holograms. And what it does is that the HoloLens assigns its own coordinate system to each of the holograms with a world anchor. And so when you walk outside the room and go back in, the holograms will stay stable at the same position. So the world anchors make sure they stay at the position, even if you go outside. And the awesome piece is also you can persist those. So even if you close your application or, shut off the device, then turn it off again, launch your application, give the HoloLens a few seconds to recognize the space again, you'll notice that the hologram is still at the same position. So when I go back home to Dresden in Germany and go to my office, I will actually see some holograms there. They're still there, even though I'm here, right? This is done with the world anchor persistence, and that's an awesome piece, and you want to use it to make sure your holograms stay stable, even if the user walks to different places and different rooms. Share holograms with the world. So when you develop one of the awesome HoloLens applications, you want actually to share it with the world outside there. And one thing to do is with a mixed reality capture. So the HoloLens has a built-in kind of a capability to record your video because it has also an RGB camera in front and combine it with the rendering. But this has a few downsides. First of all, your experience will drop to 30 frames per second. And then also it will not have a high fidelity color frame rendering because the camera is just a small, tiny camera. And there's a better solution. So one of them is called Spectator View, which Microsoft open sourced. So you can basically take a DSLR camera, mount a HoloLens on top of it, and then do the actual computing on a computer. And then it composes also the holograms together with the very nice, footage from the DSLR on the computer. And you get very awesome results. So you've probably seen some of the high-end cameras Microsoft uses on stage. This is called the bird's eye view camera, and the Spectator View is the small version of it, if you will. And Microsoft released all of that open source, so you can build your own. So take a look there. And by the way, we also have a solution called Miro, where we can take the stuff from the Spectator View. We actually rewrote the capturing pieces and changed a couple of things and basically provide you a turnkey solution. So ask me if you're interested into our solution as well. Yeah, don't reinvent the wheel. Like I said, there are a bunch of open source projects out there. One of them is also the Holo Toolkit for Unity, so take advantage of that. Yeah, offloading is an option. So the HoloLens supports so-called holographic removing. So you can actually render something on a computer and then stream that into the HoloLens. So it takes the input from the HoloLens, head rotation, gestures, and so on, sends this to a computer. The computer computes the scene, and then a video stream is sent back to the HoloLens that shows you the rendering. Of course, this has latency issues, but if you have a good Wi-Fi router, you can get those very short. And this makes sense for like large polygonal models you cannot reduce, that you still want to show at full resolution. and you can, have a static scene, so that works well. And you can also use that holographic removing to shorten your test cycle, so you can actually, remove into the HoloLens device and put it on while using Unity to actually play back the scene on the computer, but see it on the HoloLens. And there's also the holographic simulation, where you can actually simulate the emulator in Unity itself, and you can use an Xbox controller to simulate the hand gestures and head movement and so on. So pretty awesome. So use that. All right. So thanks for the um, attention. And we will have a few more talks today and tomorrow from my colleagues, Jesse and Mark, about design and business. And also, you can reach out to me directly here after the talk. I can answer your questions. And of course, you can also find me online. So feel free to check it out. And thanks for your attention. And yeah, have a good day.